Assalamu alaikum, sir. Good afternoon. This is Kajiana Sabib. Thank you, Nafis Ahmed Chishti, sir, for giving me this opportunity to present my topic, which is Mod 10 counter using IC 4026. So, this is the first slide. So, let's go to the next slide. The second slide is my group member. So, group member name actually. Then, let's go to the next slide. Here is objectives. So first of all, introduction, then digital clocks, then 7 segment display RF, then last one is electronic device. So here is the introduction here. Introduction, the first thing is counter. Counters are used for continuing anything in electronics. Counters are used for the counting of events on each receive input pulse. The 7 segment display are used to display the values of count are known to be oldest way to display counter values. So let's go to the next slide.
Assalamu alaikum, sir. My name is Mahmoud Akhtar Sadia, and now I'm gonna discuss about this slide apparatus. For this project, we need some apparatus. First of all, we need 426 IC. Then we need a resistor. Here for this project, we are using 1 kilo ohm to 1 kilo ohm resistors. Then we need push switch, connecting wires, battery, and 7 segment display. So now let's move to the next slide. So in this circuit, we will discuss about equipment. There is given two figures. In figure 1, we will discuss about IC 426. What is IC? An integrated circuit, IC, sometimes called chip, microchip, etc. It is a semiconductor wafer on which thousands or millions of tiny resistor, capacitor, diodes, and transistors are fabricated. And how does this work? It's miniaturized active devices like transistor and diodes and passive devices like capacitor and resistance. In this circuit, the counter will advance after 1 minute or after every second depending on the value of resistor selected. So now in the figure 2 we will discuss about the 7 segment display. So the 7 segment display is the common cathode CC in the common cathode display. All the cathode connection of the lead segment are joined together to logic 0 or ground. And how does it work? So first of all, we have to put our multimeters black lead on pin 3 or 8. Both are common pin as they are internal connected. Now put our meter red lead on any other pin such as 1 or 5. If any of the display segment glow, then the display is common cathode. Thank you so much, sir. That's all from me. Now rest of the presentation will be presented by my next group mate. Thank you so much.
Myself Kajidul Islam Shamrat. Now I am describe the circuit diagram. The 4026 is a decode counter integrated IC with the decoded output for the driving a common cathode 7 segment display. An advantage of this IC is that it has decoded the counter functionally together with a 7 segment display driver. The CD4026BC is manufactured by the Texas Instruments Company Corporation. In the IC currently used for the simple GCSE type project circuit. It comes in a 16-pin plastic dual in 9 package for use with strip boot and breadboards. This IC is based on the CMOS technology and will operate from the little 3 voltage minimum to 18 volt maximum. The absolute maximum rating is 20 volts. It can be there for the interfaces with CMOS 3.3 volt and TTL 5 volt system directly. Since the 7 segment LED display consumes the much power, this chip has a special function display is enabled in DEI draw pin 3, which has to be the high when a display is required. This is useful if you had many displays panel because you have to switch them on only when required, thereby the saving power. For a simple GCSE type project with a 7 segment panel, it is the best practice to this pin high to the positive voltage rail. The clock inhabitants function at 2 is used when you want to stop the count by blocking the clock signal at pin 1. Since it is the applications, we will not to stopping the counter this way. It is the best to try it to ground to keep it low at pin number 15. And if you try to high when it is would be inhabiting the clock signal in pin 1. The carry out of 5 produces the 1 pulse at the count of 10, and this is the usually use a clock pulse for the next counter stage. Since we have the only one stage in this application, we leave the pin unconnected. The displays enable output DEO is pin 4 and the ungated C segment UCGS is pin 14 are the required the special driver circuit and therefore the not connected in the simple applications. In this circuit, we use a 1 kilo resistor and also known as a pull push down resistors to keep the logic states of the pin 1 and the pin 15 slow. Without this resistor, the electrical state of the pins will be remain floating, making a circuit unstable. We also use the PTM switches, which provide a positive pulse for a short moment. A short positive pulse to clock the pin would make the counter increment by the 1, and the 7-segment display would then display the numerical number 1. Further presses of the PTM switch 1 the increase the clock number and the display shows the count. However, pressing the switch PTM S2 is causes a positive pulse to the into the pin 15 initiating a reset of counter, and we see this the documents from the experiment. The first count is 0 and second is 1, and after that it is a mod 10 counter. Its count 0 to 10. This is the experimental data. Result is experimental data is active as 7-segment display. It has 7 different diodes and activate from the A B C D E F G H, and we active the 0.
Assalamualaikum sir, my name is Humayra Rahman and I will discuss about the experiment. In this experiment, we design a mod 10 counter using IC 4026. When we will implement the counter in real life and design a counter circuit, the switch counter starts from 0 and it advances 1 each time whenever pin 1 receives a positive pulse. When we will press the switch for the first time, numeric 1 will display, and after pressing the switch again, numeric 2 will display, and it will give us the second output. In similar manner, 3 and 4 will display, and when the count reaches to 9, after that it will again start it counting from the 0. By completing this experiment, we have become familiar with CD4026 is a Johnson counter IC, commonly used in a digital display. It has a 5-state Johnson decode counter with a decoder which converts the Johnson code into a 7-segment decoded output. To put it simply, it will convert the input into numerical display and can be seen in 7-segment display or with LED. For this experiment, we use Reference of Digital Fundamentals by Thomas Floyd and AIB Rail Lab Manual, Department of EEE, Faculty of Engineering. In this experiment, we talk elaborately about how to design a mod 10 counter using IC 4026. That's all from me. Thank you.